Obviously, the political landscape is changing very rapidly at the moment. I saw on the YouTube of Enphase today, and it was a video of old mate Joe Biden in the Enphase factory. You guys are known right around Australia for your parties at All Energy. Everyone, welcome back to the Nexus Point Podcast. My name is Luke Cove, and we're here at the Lightning Energy showroom recording this live now. I've got Duncan MacGregor here from Enphase. How are you going, Duncan?
Oh, great. Thanks, Luke. Good to be here.
It's good to have you here. We've been trying to get you here for a few months. You've had us waiting since about November, I reckon.
Yeah. Life's busy at Enphase. There's so much to do.
Yeah. Well, the notorious Duncan MacGregor. Now, you've been in the industry a really long time, and you've worked with Enphase for a while. Can you give me a quick rundown on that?
Yeah. So I've been in the solar industry, since 2001. So what's that? Pushing 24 years now.
Wow, one of the originals.
One of the originals. There weren't many of us accredited installers back in 2001, actually, and the industry changed so much over the years, and it's been really interesting to see the change and the growth and work with a whole range of different technologies, products, and see the development of technologies over that 24 years. And I just love how much good tech there is now in solar.
Yeah, so you would have seen a lot of companies come and go in that period as well, I'm guessing.
Oh, yeah. We all know about the solar coaster, right? And there's been some really interesting times and big fluctuations in the industry as it's gone through, growing pains and changes throughout the years and different incentives. So all have been big factors in solar that is today, the industry today.
Yeah, I think there's always going to be big political change, particularly in democracies. There's constant battle between left and right, which is a funny thing that's been happening lately. Now, obviously you're working at Enphase now. So how long have you been at Enphase?
Well, I started Enphase all the way back in 2013. There were actually just two of us in the country when I began. Enphase just kicked off with an office here in Melbourne, and it was very early, and the product was very new. There had been a lot of success in the US with Enphase and the microinverter, and Australians were starting to become aware of this technology in the US, and we're really getting curious about it. As I was very new to the product, I'd come from an installation background. I'd been installing for well over 12 years previous in the solar industry, so I was really curious to discover more about the microinverter technology and just really explore the opportunities it could have with advanced technology.
Okay, so was Enphase the first AC technology to come into the industry? Did they basically invent the AC microinverter? Would that be fair to say?
Well, I love this question, and I have a lot of arguments at Enphase saying, by the way, you weren't the first microinverter company in the industry. Yeah. So Australia's quite an interesting market. So 1999, there was a product in South Australia, and that was called the Oki 4. And there are some people in the solar industry who still remember this product. And there were small solar programs happening all over Victoria and South Australia. And one was called, it was a very big deal at the time, 100 Roofs program. You can imagine how big the industry now. It just sounds, so small. When
did that last week.
Yeah. I don't know how long it took to put 100 roofs in, but some of those systems included as small microinverters on those installations. Now, over the years, I've actually been to some of those sites and seen those original systems. So even had a sample of one of those original products. So there have been a few manufacturers of microinverters over the years, actually.
Okay, yeah, that's interesting. So Enphase started in America, and I think it was 2006. Do you know the story of the founders fully, of how he got into the Enphase microinverter, how he created it?
Yeah, so as the Enphase story goes, there are two guys that came out of the telecommunications industry, out of Cisco in the US. They call it the sort of Telecom Valley in the US, and that's north of San Francisco. And there was Martin Fournage and Raghu Balleur. Both of those two gentlemen were working together and said, hey, we want to make a microinverter that's commercially viable and make something that's reliable and can be developed for the entire solar market. And so they went all in 2006, developed that. Enphase then grew and then had early products in the US, and then they were listed on the US Stock Exchange, I think from memory around 2011, around that time.
Yeah. Okay. So about 5 years, and then they went pretty big from there. And I believe the Enphase has a fair portion of the share in America, of the market share in America right now. Correct?
Yeah. So they have a very big presence in the solar industry in the US, and look, the numbers will vary, but the number is around 60% of all inverter sales in the US are Enphase. Yeah.
Yeah. Okay. Do you believe that is because of the regulations around fire in America and safety features there? I'm told that I was sitting on the reg board. There's some people from the fire department, which are apparently very influential, which said that safety for firefighters was something that's really important for them. So they really pushed that as a mandatory thing.
I think it's good to put in context because Enphase was very successful up until regulations became a lot tougher in North America. But certainly the regulations have become very aware about safety in the US, and they've brought in rules such as the rapid shutdown requirements for inverter systems. So all solar inverter systems need a certain method around safe shutdown. Now that rule is specific to North America, and the microinverter product, the design of the technology, makes it very simple for installers to achieve the regulation because of the design and architecture of the product. It meets the rapid shutdown requirement just by simple installation of microinverter.
Yeah. Okay. Is it steel conduits mandatory in America? Is that right?
Well, steel conduits are very commonplace, so they're used on solar installations. So
I see a lot of pictures online, and see steel conduits going across the shingled roof. I just think, oh my God, like it must take 3 or 4 days to install a 6.6 in America.
Yeah, and I sort of joke a little bit with installers here and say, you think you've got it tough here? Have a look at what they're doing in North America. These are quite onerous requirements on installations. Yeah.
What about the pre-applications? I've heard from people at Tesla it can take 6 months to get the pre-approval for an installation. Do you find that as well, or?
I think it would be on the regulatory body in which sort of council area or local area you're in. It does vary, but there is a lot of paperwork, and the costs can be quite high too for the initial application.
Sounds like someone needs to maybe deregulate over there a little bit. Maybe we won't go down that rabbit hole right now. It's good that they're putting safety right at the forefront. So Enphase, obviously an American company. So tell me about Australia. How long has Enphase been in Australia? Like, have you guys got offices set up here, obviously, and support staff? Like, what's the team like in Australia?
Yeah, so it's had a lot of growth over the time I've been at Enphase, and I was really fortunate to come on board just as it opened in Melbourne. And we've, give or take, we're up to about 20 staff now. So they're just, just a handful of us back in 2013, and we've really increased the numbers of staff to support the market and support all of the installers and system owners with those existing Enphase systems over the years. So we've got a Melbourne office, and then we've got a range where customer support, marketing, sales, as well as training myself. And we've got field applications engineers as well. Now, we're not all based in Melbourne. We're all spread around all across Australia to meet the requirements of each of the states. So New South Wales, we've got staff in Queensland, South Australia, and then we support all of the other regions as well.
So Enphase has an installer network right around Australia, and you essentially have like account managers in each city or each area where you have a lot of installers to help assist the installers with installation, tech support, on-site, field techs from time to time. I know I've called you out to my sites a couple times, I'm pretty sure. So you guys support your installers right around Australia, directly? It's a very hands-on thing, or?
Yeah, and I'd like to describe it that way. I'd say that we're a very grassroots as an organisation. We're there for the installer and the system owner. We really understand what it means to have a solar installation. We really like to help you on the journey, whether it's a homeowner or the installer. So we have field applications engineers, which is a fancy name for people that help support design and installation requirements to ensure that the installers are meeting the technical requirements of Enphase and also meeting the regulatory requirements so that you're getting systems in and putting them in the correct way. And then we have the account manager. Account managers are there to support you, the installer businesses, to help manage, all of the other operational requirements and sales requirements that are needed to help understand the product and help your knowledge so you can share that with the system owners.
Yeah, I have to say Enphase is one of the most helpful inverter manufacturer companies that I've dealt with, and they've got a really good culture in the company. And since we started working with them seriously, I don't know, nearly 2 years ago now, we've started doing a lot. They've really kind of brought us into the family, which you don't really get that vibe with a lot of other, the Chinese companies. You get it a bit less. Maybe you get an exclusive WhatsApp chat. That's about it.
It's really unique, isn't it?
Yeah.
It's interesting you say that, because I love that story about how installers with Enphase, we find that there's this sort of natural network of Enphase installers around the country that like to chat to each other and share support. And I think that's a brilliant thing that's happened just naturally by the installer network. So you guys, it's interesting working with Enphase and watching how installers evolve and share information within the community. And I just think that that's a really nice organic way that the product works.
It's interesting how it's created a little kind of cult thing. It's a bit like the Freemasons. We've got our own handshake and everything, so we identify. No, we're not that extreme. But I will say with Enphase though, you guys are known right around Australia for your parties at All Energy. So every year it's like, are you going to the Enphase party? Oh, the Enphase drinks is going to be huge. It's always like the biggest one at the conference. So that's always something that I look forward to, which is, coming up again this year.
Yeah, great. We'll make sure there's room for you to get in this year. Yeah, I'm sure it'll be popular now.
Yeah, I normally register like 8 people. Last time we brought a whole crew, we brought half the company. Coincidentally, we got an award too, top installer in Victoria. So thank you for that.
Oh, congrats. That's great.
Yeah, we've got that one downstairs. But I wanted to ask you some technical questions. So from a homeowner's perspective, there's a lot of inverters on the market. There's a lot of other products, string inverters, power optimizers, and things like that. Now, to be totally open, Enphase is generally the most expensive of all the products on the market. So why would a homeowner consider Enphase over a string inverter or power optimizers, something like that?
Well, Enphase is one of those products that is a very high quality product. And in order to understand the product, it's really important to understand the story around what the microinverter does and what the benefit is, because it's an investment and it's a long-term investment. So some of the things that are really drive people to Enphase in a highly competitive space, there are a lot of manufacturers, of course, and people have many good choices now. It's really a matter of understanding and knowing what the benefit will be to you as a customer.
So historically with Enphase, people kind of default to, it's just for shading. If there's no shading, you don't need it. Like, do you believe that's a fair statement, or do you think that's a misinterpretation of the product?
I think it's a logical statement, and it's quite natural for people to say that, because it might be that they haven't looked at all of the diverse benefits or functions of the microinverter system. So generally people go to that because it's quite well known, or very well known, that for shading, Enphase is very good. It's the design of the product enables it to overcome so many limitations that shading puts on solar panels, that it minimizes it tries to minimize the impact of shading on an array, and it does that very well just by the fact that it's one microinverter per panel. That said, there are so many diverse features and functions of the microinverter product, and I can give you a very long list of those.
Give me the top three.
And you're selling Enphase. I should ask you this question, right?
I know what I want to say. I want to hear what you've got to say about it. I want to hear it straight from your mouth. I mean, we've obviously got the flexibility and the safety, and panel level monitoring and the app.
Exactly.
I mean, there's so many great things about Enphase. But I mean, what we're finding lately is that a lot of other people are catching up, and even I think the Tesla Powerwall 3 doesn't come with optimizers or anything. They don't recommend it, but they reckon it's got a rapid shutdown feature in it, so it's kind of equally as safe. So I don't know if maybe other inverter manufacturers are catching up, but I mean, even Fronius, Fronius could theoretically probably, there's a higher probability of there being a fire on a string system. Well, I don't want to. Let's remove Fronius, just any string system. I don't want to talk bad about Fronius, but there's a higher probability of a fire or arc fault on a string system than an Enphase system. You would agree, yeah?
I would agree, and I'd probably say it's a high risk, really. All systems are designed, have to be installed in the right way, and you have to put a lot of work in on non-Enphase systems or string systems to create a safe installation. The beauty of the microinverter product is, and you'll often hear it's called it's all AC. Well, it's AC off the roof, so AC wiring is the same as the home wiring. That meets a certain set of criteria in the standards, and the standards look at DC and AC slightly differently, and they look at DC as saying much higher risk, so you need so much additional safety equipment to install DC wiring in a property. And just by looking at how the standards address AC and DC wiring is enough to say it's trying to minimize the risk. Whereas AC wiring got a lot more flexibility with the way a system is wired, and there's all the safety equipment that's included. We call them RCDs or RCBOs, which are circuit protection that provide additional safety in the switchboards now. They're very commonplace nowadays, and the wiring is also controlled much more safely across the property. There's no live DC cable running across the roof. I mean, those are only just two examples. There are obviously more examples.
Yeah, it's interesting, the argument about whether DC is safe or not, because a lot of people, they jump back to when DC is installed correctly, it's very, very low risk, is what a lot of people say to me. And I've been in the industry a long time. I've seen a lot of installers come and go, and you see a lot of younger people in the industry, apprentices and stuff. And a lot of the time you have maybe a team of installers. You might have an experienced installer on the ground, 10, 15 years experience. He's wiring up the switchboard, the Envoy, the inverter, whatever. And the guys on the roof are often first, second year apprentices. And yes, if you can go check on their work, definitely. But I think there are instances in the industry where inexperienced people are doing the work on the roof and systems are not installed correctly, and they do pose a risk of fire. And my argument for Enphase is it's harder to mess it up. It's easier. And if you do mess it up, you're not going to have a fire. So there's less room for human error in the installation, which is a big thing because humans just don't get it right every time, unfortunately. That's why, car manufacturers use production lines and robotics because, humans, is just the quality control is not always 100%. So at least with Enphase, even if the quality is 98%, that 1%, that 2% of the time, at least you're not going to start a fire if something is wired incorrectly, if it's a loose connection.
Well, you've summarised a really good point there. There are a lot of moving parts in solar when you're installing. A lot of variability. No two sites are the same. You've got to be really bang on with all of your connections, all of your terminations across the roof, the positions of the isolators. There are so many elements to it that you're absolutely correct. DC wiring, if something is missed or something isn't connected up in the right manner, it can lead to a much higher risk in that installation. Whereas the microinverter system, purely the fact that you're running AC cable up to the roof and not running a higher voltage DC cable around and making DC cable connections, you're minimizing all of that. You're removing that risk element from the installation. Now, and I just wanted to add in there about that. One of the elements was safety, and people often think about, well, I put the system in today, it's working fine. We've got to think now that solar is long-term play, and it's not day one. And you look at the fatigue of all of that electrical componentry and up in the weather over that life of the installation, whether it's beyond 10 years, it could be 15 years in Enphase's case is a minimum or longer. Equipment gets fatigued, and safety risk can increase, or the risk can increase over time.
It's interesting. So a good friend of ours, Captain Richard Burt, obviously you know him, but yeah, from the Las Vegas Fire Rescue, he's come down and talked to us on behalf of Enphase twice now about fire safety. And we ask him a lot of questions like, okay, if you install 1,000 systems this year, 1,000 or 100,000 systems this year, how many of them are going to catch on fire? You're a firefighter, you must be able to put a number on that. And he goes, just because you install a system this year doesn't mean it's going to catch on fire this year. It could actually catch on fire 5 years down the track. He said a lot of the fires that we are seeing are with systems that are much older, and even the company's gone bust years ago, and 6, 7, 8 years, and then the fire starts, which I have seen a lot. Most of the, well, not seen a lot, but I've seen a few too many. Often they're in Queensland, rooftop isolators catching on fire, because there's no inspections in Queensland. I think we've gotten rid of rooftop isolators nationally for DC. But I mean, that's a good thing. With the rooftop isolators now, with Enphase, do you recommend disconnection points or rooftop isolators, or what's the current go-to there? I know we were on the DPs for a while.
Yeah, so a lot of installers still using AC isolators, which they have AC isolator is a big weatherproof switch that's installed at the array for it makes for a nice point of connection between the AC wiring and the Enphase cable system that we supply as a junction on the roof. Now, there's no real risk in using those compared to DC isolators. So from Enphase's perspective, we don't say one preference or another, and installers can make their own choices, and there's no difference in safety. There's just sort of practical reasons why you might choose an isolator, just for it makes for a smooth wiring experience, and we have there are some good solutions out there being supplied through the wholesalers, as you'll know, for those as well.
I think a good time to consider Enphase is any time. No, is a good time is with new houses, double-story houses. They just have the single stud going on the top level. So you have to get the DC or AC cabling up through the stud, and it's only about 90 mil in between. So you can't really run DC in the walls internally. Your only option, if you want to hide the cables, is to go with AC cabling. So that's one example of when I think it's a really good idea to go for AC with these real technical cable runs up to the roof and stuff, apartments and things like that.
And pre-wiring, for solar on new builds is great too, right? If you can run an AC cable in the building and have that ready, or you get in at the time of the build, it's very neat. That's the beauty of AC wiring, is it can run in the wall cavity. And a lot of installers don't want to be having to put so much effort into plan out the cabling. It's got to be simple and an easy installation. You don't want to overcomplicate it, right? So this is where AC wiring can be really, really helpful.
Yeah, so we have a lot of customers that are three-phase as well. So can you explain to me in your words how Enphase works with three-phase? You obviously have the three-phase trunking cable that picks up the microinverters. How does that work?
Yeah, I think we probably need to talk a bit about the microinverter itself in terms of what it does, because
we can talk about that and then go down the three-phase. Yeah, so tell me about the microinverters. Because I mean, obviously, the first thing that anyone's going to think is a solar panel is DC. So how does that convert from DC to AC? It does that on the roof?
So the microinverter does it at the roof level, and it does it under the solar panel. And it's we call it a low-powered device that's converting the DC electricity from the solar panel into and converting to AC electricity and synchronizing that onto the grid. So it's a grid connect inverter. So when you're putting up one microinverter with a panel on the roof, think of it as one system. You're putting up lots of small individual grid connected inverter systems on the roof. And now we the beauty of that is it creates independence between each of the panels on the roof. Now, the unique thing about the microinverter is we make a couple of different sizes, power outputs to match the panels that are being used, but they are what we call single phase inverter. So they connect onto one phase on the home. Now, you asked about three phase, and this is where it gets
I might have
cool.
jumped to the gun, but explain to me how does that work exactly for the people that don't know?
So when Enphase is used as a product, we say we can use it on 1, 2 or 3 phase homes. Now, most homes are 1 or 3 phase. 2 phase is quite common in very rural areas and more remote places.
Great chance for Enphase if it's 2 phase. You're just like, got this one in the bag. There's not really any other options, right?
No, it can be very difficult with other product topographies to find a suitable inverter for those connections across a range of supplies, 1, 2 or 3 phase. Enphase, it's the same inverter, and all we really need is some way to get the inverters to sit on different phases, and we do that through a cable. And that Q cable we have a single phase version, we have a 3-phase version, and that the 3-phase version has different conductors inside it, and each of those conductors are wired onto the different phases of the home. And so internally in the cable, and the installer's plugging in the microinverter, each of the microinverters will be sitting on a different phase, and we change the phases inside the cable. So you get a nice balanced system that can connect on over 3 phase. So it's purely just the cable that we're changing for 1 or 3 phase install. The microinverter is the same.
So we're just alternating the panels like 1, 2, 3, 1, 2, 3, and then you're splitting the panels between each phase. So with 3 phase then, so I'll see if you can explain this better than me. So if someone's pulling on one phase, they're pushing on another, it's going to balance out through the energy meter as far as their bill in the terms of net metering.
Yes.
Is that correct? Yeah. I know I always struggle to explain net metering to people.
So the interesting thing is even a lot of electricians might not be aware of how it works in 3 phase because maybe they haven't had to work in 3 phase much. Yeah. So the curious thing about, and it's different in different parts of the world, because this is the thing, if you've got anyone from New Zealand. So this is Australia. Yeah. But New Zealand's completely different to Australia in how 3 phase works.
Okay.
Which is really curious, right? So in Australia, the meter is connected to 3 live cables, so 3 phases coming into off the street. Those conductors will then be wired across into the property. We have other cables as well, like neutrals, etc. But that meter is looking at each of those lines and then the houses, generally on larger homes with a lot of electrical demand, will have appliances connected across 1 or 3 of those phases in the home. So lights would generally be on 1 phase. A very large air conditioner would be on 3 phases. You might have a fridge on a different phase to the light. So the electrician is trying to balance out the load in the home, so it's an even power flow through the phases. Now, the solar is connected onto the phases, and it will the solar will the meter when it's if you're drawing a power. Sorry, let me think about this. If you're drawing power on say phase 3 on a 3-phase home, but your solar is only producing on phase 1, you're going to be like, well, how do I benefit from the solar on phase 1 if I'm got a load on 3 phase? Because you could have just 1 phase of solar on the house, for example. And the meter just says, okay, well, I'm using 5 kilowatts on line 3. So the meter will see the solar on line 1 or the first phase, and it will basically subtract that off line 3. So it'll get a 0 reading. If there's 5 kilowatts of solar on line 1, it will there will be a 0 reading in total on the meter. So the meter doesn't see the difference between the phases. It's just looking at the total in and the total out coming through it.
Okay, yeah, the meter doesn't see the difference, yeah. Okay, so it's interesting. So if you had a 3-phase system, hypothetically, and you say, I don't know, on the 3rd phase, you had a couple of air conditioners that were using a lot of power, could you just put a single-phase system on the 1st phase and just be like, yeah, whatever, the meter's going to work it out? Or you recommend going for 3-phase to try and balance it out? Or would you recommend even further, like rewiring the switchboard to try and balance the loads?
Well, you've got a couple of elements here. Technically, you can have all the solar on phase one. The meter doesn't see it any differently. The load will be measured and offset against whatever the solar is producing on the other one of the phases. So it'll work itself out to be correctly measured. However, there are distinctions and there's considerations, because an electrician's going to have to look at the building and say, well, technically you really need to have an even amount of loads across the phases in a home. You can't just put everything on one of the phases. So in order to get things well balanced, ideally you'd have maybe a 3-phase solar system balanced across the phases. And in the regulations and the connection requirements, they're generally with solar, there's generally rules around this. It says, well, if you've got more than 5 kilowatts of solar in a 3-phase home, it depends on, you might want to split that across the different phases. Just depends on the size of system as well you're putting
with DNSP restrictions as well to balance the loads. Yeah, okay. Yeah, it's interesting. Years ago when we first started doing batteries, when we had like a single phase battery on a 3-phase, we thought we had to like load up all the loads on the first phase. We were rewiring the whole board, and then we realized we didn't have to do that.
Well, of course, if you had a meter that was reading each of the phases individually, you would have to put all the batteries on phase one. On the phase that the loads are on. But now that because of Australian meters being able to that don't differentiate between the phases, you can have a battery on phase one and it will be offsetting or discharging against any of the loads on any of the phases. So it's quite a unique, it makes it it's nice because that type of metering makes the job very easy to manage from an installation perspective to get the best outcome for the system owner, because it's an easy to get the benefit no matter how the system is installed.
Yeah, okay. All right. Well, let's assume we haven't lost anyone at this point with how technical it's getting. Let's go even more technical while you're here, because I know you're a technical guy. So let's go right in. So with the 5P battery, I want to talk about the battery for a bit. So it's a 5 kilowatt hour battery, and you have the Enphase IQ gateway. And usually I think you recommend 2 or 3. I mean, you can do 1 5 kilowatt hour battery, but we usually go for at least 2, sometimes 3. So what do you think is the recommended setup then? Are we, like, say if you just had 2, that's probably the most common, 10 kilowatt hours of storage. Would you recommend we split them between phase 1 and 2, or would you recommend having them all on one phase? And like, how is that going to work for backup? Like if we had 3 batteries, that's just still single phase backup, or is there 3-phase backup? Can you elaborate on that?
Yeah, and I think, again, it's a really good question. We get asked this all the time from system owners. And they have to, we've got to clarify this a bit too, because battery systems that Enphase supply are grid tied. So you'll have a grid connected solar system and customers benefiting from that, and you want to maximize the solar and put a battery in, and so the battery can then discharge into the loads when there's not enough solar or at night time, and can support backup. Now, when Enphase specifies installations, we always say the battery must be on phase 1. Now, whether it's
the first battery or
all of the batteries, so if it's 1, 2, 3, or even 4 of those IQ battery 5Ps, they will up to 20 kilowatt hours we recommend being installed as a maximum on line 1 of the home. Now, the reason why we specify line 1 is that microinverters are single phase again, and so when we run backup mode, that battery will support single phase loads on line 1. So when it's grid connected and the grid is operational, because of the way the meter is, as we described, the aggregate meter, the battery will happily offset any of the loads on any of the phases. But when the grid is not available, the battery will then supply only on L1 or the first phase, into the home. So it's a single phase backup product for loads on phase 1.
So, I mean, there's a bunch of reasons that come to mind. Is this because the continuous output of the battery it's 3.76 kilowatts of power that it can output per unit?
Yep, great guess. I'll correct you on that one. 3.84 kilowatt of continuous output power. That's great. So
But that doubles per battery that you've connected. So if you load it all up on one phase, you're loading up the continuous output. But if you split them across phases, then you've basically compromised that output and your backup capacity in a blackout.
So the batteries will, in a blackout scenario, only the batteries on the first phase will continue to provide backup. So the way the Enphase system is currently designed is for the battery to support one phase loads in the home.
So now, single phase backup.
Single phase backup, that's correct.
So 3 phase. So just to clarify this one for anyone listening, so we have single phase microinverters on the roof, and you have the Q cabling, which basically is split into 3 separate lines. So those single phase microinverters are then split to 3 lines going down, and then it goes into the IQ gateway, and then you have your batteries connected to phase 1. So they're technically on the single phase, but they're going to be charging up off phase 2 and 3 through the net metering. It's going to know when you're sending power on phase 2 and 3, and it's going to essentially tell the batteries to charge up, kind of diverting that power from phase 2 and 3 back into phase 1 to charge the batteries. And then if the grid goes down, then it'll kick in, so you have all the batteries on backup on phase 1.
Absolutely. Yeah, so that's
easy.
Quite a lot to take in.
Yeah.
So multi-phase is interesting, right? You can have really good outcomes across 3 phases in homes. And we're seeing, as I think you'll be seeing, Luke, with like electric vehicles, etc., a lot of houses are now getting 3-phase put in.
Yep. Yeah, it's interesting trying to explain that to homeowners. And at the end of it, you kind of just like, trust me, bro, it'll work. Like 3-phase out there, we're just going to do this. But so you can get like a really high continuous output, or you can get a surge current. Sorry, I forget surge current's the correct word. The short-term current when there's a high loads, when you switch over to backup and you have like air cons and stuff that like spike. So what's the deal there?
Yeah, absolutely. And this is really important, and something that's really worth looking at when you're looking at storage products. You want to have a high surge capacity in the storage product. So what that means is that the generally, in Enphase's case, it will supply 200% capacity of its nameplate rating for 3 seconds. Now, the question is, why do you even
what
need
type
that?
of loads are we talking about?
Well, with electrical loads, depending on the devices, you can get a lot of what we call an inrush current when they turn on. So if you're starting something from cold or cycling something, so fridge compressor motors and things, what used to be quite demanding, and so they would require a lot of inrush current to get them turning over. So things like compressors, even a lot of electrical demand appliances, maybe air conditioners, for example, will have a slight increase in rush current. Once they start running, they'll settle back down to their continuous capacity. So if you're in backup, you really need a way, and this is purely for backup, so if no grid is available, you need a way to be able to support those loads if they're turning on and off when you're in backup mode. Otherwise, even though you've got all that capacity there, you may just not have enough instantaneous power to help them turn on.
Yeah, okay. What about the chemistry for the battery? Do you want to tell me about that?
Yeah, so as a lot of people might be aware, like lithium-ion chemistry is becoming more prevalent in the solar industry, and Enphase uses lithium iron phosphate batteries, cell packs in the Enphase battery. So, and again, Enphase, we describe the battery as an all-in-one, which is a particular type of product that's used in the solar industry, which really means it's factory manufactured. The inverter, the microinverter, the battery is all factory fitted. So there's no extra wiring required of those components because it's all in the one housing.
And you have your microinverter technology built into the battery pack as well.
That's correct. And that's the unique proposition about Enphase. So Enphase's strength is in the microinverter. That's what it's been manufacturing for many years, and over 80 million of those units have been supplied worldwide. So it's a big number of microinverters, and all of Enphase's knowledge is in that microinverter. And they have really pushed the boundaries on advanced the technology of the microinverter. And so it's very sophisticated now, and we can take that product and we can use it inside the battery. In fact, there are 6 of those in a battery, and it enables Enphase to manufacture a product that doesn't require any external cooling like fans or ventilation, because we're spreading the load across multiple microinverters inside the battery. So, and they communicate with the other microinverter products on site, and enable a lot of redundancy in the battery itself. So high power, we would argue no single point of failure, which is a line that we like to describe with microinverter architecture as well.
Yep. No strings attached.
No strings attached, yeah.
Yep. All those slogans. Yeah. No, that's good to have that no single point of failure, and the microinverters built into the battery. What do you think is probably an awkward question. What do you think is the key difference between the Enphase battery and Tesla Powerwall, or the Tesla, the Powerwall 3 is kind of a different kettle of fish, but we used to compare the Powerwall 2 to the 5P, and they were similar, but there was a few points that Enphase really kind of beat them on. What are those?
Yeah, so Enphase's, I guess, key point of difference is that flexibility with the product. Interestingly enough, we're coming in with a smaller power pack. So I think, I'm not sure the capacity of Tesla, it's 13 kilowatt hours, so it's very sizable.
Yeah, 13.5.
It's very large and heavy, because batteries are heavy, and the higher the capacity, the heavier they're going to be on the home.
Yeah.
So it can be quite difficult to maneuver and install. The Enphase battery, the 5P is a 5 kilowatt hour battery. To get the equivalent Tesla capacity, you'd probably put 2, for argument's sake, 2 of those batteries
2 or 3, yeah.
Although you'll take up slightly more wall area, you're going to have a much more manageable product for installation. When working in with the Enphase product, of course, because our microinverters with solar panels are very flexible, can work with a range of products. But with an Enphase battery and microinverters, you're getting the seamless communication, so single app monitoring for all of the components on the installation as well.
Yeah. No, it's good. We used to do a lot of Enphase systems with Tesla Powerwall 2 when you guys didn't really have a battery solution for a while there. I know you did 5 years ago. There was the smaller ones, and then didn't really have much. I think even Enphase guys were recommending to us to use Tesla Powerwall 2, and there was a really good integration there. The batteries worked really well together. But now Tesla Powerwall 2 is out on the market, and Tesla Powerwall 3 is kind of a completely different thing again. So yeah, different options there. But with you're probably nearest competitor as far as inverter manufacturing goes is SolarEdge. So what do you think's the key difference between, say, SolarEdge with the power optimizers and Enphase with the microinverters? Yeah,
so it can often make my skin crawl when I hear SolarEdge and Enphase being lumped together in the same bucket.
They always are though. Like that's why I say when you're talking the batteries, it's always like Tesla is the benchmark with batteries, and then Enphase are the kind of the benchmark with microinverters, definitely.
Yes.
But there's people often want to compare between power optimizers and microinverters. So can you give me a quick rundown? What's the difference between the two, and why you think Enphase is so much better?
So I think the big point that's often maybe forgotten to be described is that my understanding is SolarEdge is still a string inverter product, right? So it's a traditional architecture of inverter. It's a DC inverter requiring DC wiring up to the solar array. And then it adds in with extra components on the installation. So there are a lot of parts that have to be used in that installation to, and I'd argue to attempt to mirror the performance that Enphase can get just by using microinverter and an AC cable in the home. So it actually is quite, in my view, my view of it, it would be quite a complex product, whereas Enphase is designed very neatly and simply for wiring in the home.
Yeah, I think installation-wise, Enphase is simpler. SolarEdge has got a little bit simpler. They used to be very technical 5 years ago. And, I go back to that thing I was talking about, installer error. where like SolarEdge, it was so technical, installers, it felt like they would just mess it up most of the time unless they were really experienced with the product. Whereas Enphase, you know, we had new guys on the team that are like, wow, you mean I just click this in? Like, yeah, that's it. They're like, wow, this is so easy. So a lot of installers really prefer that for that reason. But yeah, no, they are similar. I think the output that the customer gets is the same, but I think they're like two different paths to get to that kind of result, I think, or similar. They get a similar output at the end when the customer opens their app and they see panel level monitoring and everything, but how they get there is kind of totally different with AC versus DC.
Yeah. And I just think in terms of the microinverter itself, it's when we think about simplicity, we think we're uncomplicated product with one or two inverter types. We don't need many because products are interchangeable within the installation itself. And I think that additional complexity that other systems require just to get to try to emulate, say, panel level data or try to reduce impact of shade. My argument is just keep it simple. Do the product that just gets the job done without having to over-engineer the site.
Yeah, I do. I am a big fan of just keeping it simple where possible. I like the tech, but we want to keep it simple. And you know, sometimes you can argue the more things that are on the roof, the more points of failure. And you don't want to have too much tech on the roof where it can get really hot. Which is one of the arguments against optimizers is that, they can get too hot and overheat. I mean, what's the operating temperature of an Enphase microinverter on the roof? Do you know off the top of your head?
I do.
The maximum?
I do, yeah.
Oh, yes, you're the guy.
The temperature range that's printed on the back label of the microinverter is -40 to +65 degrees ambient. So that's ambient air temperature. The microinverters themselves, and the way I love to describe this is that every microinverter has a temperature sensor inside the unit, because there is a whole heap of data that is actually being broadcast onto the monitoring platform that's available for installers and for system owners. And the temperature of each microinverter is reported, and we can show. I love sharing and showing installers this too when we're having workshops, is that you can see a difference of around 15 degrees on average, the operating temperature of the microinverter above ambient. So let's say it's a 40-degree day. I would expect to see the microinverter operating, say, around 55 degrees. I'm pretty confident in saying that because I know the operation of the unit. So the internal operating temperature of the microinverter will exceed 85 degrees internally.
Okay.
And that's proven over the years as well. With the history of installations in Australia, there are in excess of 100,000 sites of microinverters sites in Australia, and all of those temperature points are recorded and referenced, and Enphase has got reams of data on the performance across very extreme locations all around Australia. So
do you have examples, or are there times of the microinverters shutting down in Australia due to the heat, or we don't quite get there, or very rarely?
No, I have to qualify this. I've got my experience and my view. Now, I can't answer for every microinverter that's installed.
Yeah.
But I've been with Enphase the entire time it's been in Australia. I've never once seen a microinverter shut down through over temperature.
Okay.
I have seen microinverters increase in temperature. That may be due more to the fact that they weren't installed as per our requirements. So what they must have is some airflow, so installed under panels out of direct sunlight. If an installation was to be done incorrectly and they were directly exposed to sunlight, they may run hotter. But the system is designed to be installed in a specific manner. If it's installed in the correct manner, it will never exceed the temperature.
What about, I've got a question for you then, bifacial panels. So bifacial is clear backsheet, so the sunlight can actually go through the panels in certain points around the cell. Do you find that's an issue, or is that fine?
Again, I'd love to be able to give you more detail. I don't have a lot of direct.
I'm thinking of very specific questions, but we've got a bifacial panel down there. It's kind of like the trend at the moment. I know there's Jinko, REA, a few companies bringing out bifacial. It's getting more popular.
Well, I can describe it another way. Enphase did say in the installation requirements that bifacials were not recommended to be used with the earlier version of microinverter, with IQ8s, they are included in the installation, so they can be installed with those. So again, all of that means that the product's been engineered and tested to work with those types of modules.
Okay, yeah, that's good. So we'll go to some other things. So I just want to touch on the warranty as well while we're here. So the warranty was 15 years. Now we've just upped that, correct? That's what you've done on just the micros, or?
Yeah, so this has created a bit of excitement. It's now 25 years on the microinverter.
Yep.
Which is, it's huge, right? It's a really long warranty, and that really I think is really Enphase investing and showing people the reliability and the quality of the product through extending that warranty. We've got a long history of making microinverters, and we've got a very, very good confidence in the performance of those units.
Yeah, 25 years is a long time, but we do get a lot of people that are a bit more senior and they're retired and they come in, they're looking for a solar system and they're like, I'm going to be here for the next 20 years and I'm going to die in this house and I just want one solar system and then I don't want to have to buy it again and that's it. And we just go, yep, Enphase and you're done. That's it. You don't have to worry about it. You're covered. Panels, 25-year warranty. There's a lot of good panels out there now to couple it with. So
yeah, it's a really good peace of mind, isn't it? And people don't want to be creating a burden when they add solar. They want to just have solar and have a solution that's going to work and not have to really worry or concern themselves about the function of that system over time. And if they can be supported and we can support them through the warranty, I think it's a no-brainer. It's a really good thing.
Yeah, no, it's good. I wanted to talk about the manufacturing as well. Now, I'm not sure exactly what you're doing. I know you've been moving around a bit. I was on the YouTube of Enphase today, and it was a video. It was a few years old, but it was old mate Joe Biden. He's in the Enphase factory talking about the Inflation Reduction Act back in, I believe it was 2020 when he took over, and they had the Inflation Reduction Act. They're bringing manufacturing back into America, and they were getting a rebate per microinverter. I think it was bringing the cost down of the microinverters, and the manufacturing was happening in America, which was great. Now, obviously, the political landscape is changing very rapidly at the moment. So what are you guys doing with manufacturing now? And are you still getting that Inflation Reduction Act rebate, or is that coming to an end?
Well, the political climate's changing in the US, and I think anyone got a crystal ball to tell us what's going to happen.
Yeah, but has anything happened? Trump's been in for 2 weeks now, and it's just sweeping changes, just reverse everything. Have you guys? I've heard they cut some rebates around solar in America already. I think people that were approved can go through, but new ones can't go. I'm not actually across it fully, but I know it's changing a lot.
Well, unfortunately, I'm in the same boat as you because I'm based in Australia. I'm not looking at the regulatory changes in the US.
But you manufacture in America, or Enphase does?
Enphase do have manufacturing globally. So we've got manufacturing plants in the US. There are also manufacturing plants over in India and China. And we've also got plants all around the world to support different parts of the product and different applications and materials globally. Yeah.
Okay, so we're manufacturing all around the world at the moment.
Yeah, it's a global company. We deliver in over 100 in excess of 150 countries worldwide. So a big representation across Europe, the Americas, and the African continent, and our part of the world as well. I think one point probably to add to that, which Enphase is not very good at describing, is the fact that the engineering of the microinverter, you might be aware of this, that it's all done out of Christchurch in New Zealand.
Yeah, I have heard that. So they've got quite a big team in New Zealand, don't they?
Yes, it's up to a couple of hundred engineers in Christchurch. It's been there since around 2008, 2009. So very early on in the company's growth. And that engineering division is called the Microinverter Centre of Excellence. So they're responsible for all the microinverters that are manufactured worldwide, and that's where all of the technical knowledge and engineering testing is all done in their reliability centre there.
But the company was founded in California.
That's correct. It's a North American company founded in California.
Yeah. Okay. Yeah. No, that's
very
good.
much global company.
Yeah. Very very global now. Well, yeah. You guys you have a lot of presence in Australia. I know I've met Raghu and a couple of the other CEOs have come down to Australia for conferences and stuff, and they're always asking me questions. How are you finding it? What's your biggest pain point? What's your issues? Be honest. Tell us what you're struggling with. So it's good that they care and they fly around the world to talk to their installers and find out what the issues are. So I wanted to just ask you a few questions about what's coming up with Enphase. I want to ask you about one thing in particular, because I was on YouTube today. There was an IQ Power Pack. It was like a remote thing for camping. Is that available in Australia, or are you across this?
I'm across the IQ Power Pack.
Yeah.
Sorry to spoil your party, but it's not available in Australia. It's a North American power pack. Yeah, so a battery pack with a microinverter in it with a few connections on that.
Yeah. Okay. Yeah. Oh, well, looking forwards then, I'll ask you a few specific questions because I know people are just gagging to hear it. Vehicle to grid, EV charging. What's the roadmap there? Do you know?
I do know.
Yeah. Well, yeah. How are we going there? Bad or is it good or bad?
Well, Enphase, when they've got products coming into market, they will announce them and share the story about those products. As people will be very well aware, there's a lot written about it. There's been even testing videos shown online with vehicle to grid solutions. And what Enphase did is that they have a car charger manufacturing arm. They took over a US manufacturer, and it's now the Enphase car charger, and they've got Enphase car chargers launched worldwide. Part of those programs are to continue to develop more features and more functions, just like vehicle to grid is becoming sort of the new focus of car charging, and there's a lot of curiosity about that. So that development will continue, and one day we'll have that available to market.
Okay. What about the next generation of batteries? What are we looking at there? I saw a sneak peek of one in a Zoom. Yeah, there was a square boxy one. Were you saying it's a smaller battery?
So, well, again, just to sort of describe that for you, with I can't give you any sort of dates or of delivery of that those products. But as you'll be aware, as a manufacturer, there's a continuous improvement in engineering and development of new products, and we're constantly looking for ways to benefit the installer and the system owner with future products. Yeah. So, we're a global business. We have products that will be rolled out around the world, and you'll continue to see products here in Australia be added to the product list that we have.
Okay. Yeah, that's good. We'll keep an eye out for any new products coming to the market. But yeah, is there anything else you wanted to talk about while you're here, or?
Oh, there's so many questions.
Yeah, we've asked you a lot of questions.
Great questions. Yeah. Oh, I've really enjoyed talking. Yeah.
Is there anything else you want to touch on while we're here, or?
Oh, well, I think, like it's, we're beginning of 2025, right? And there's, we've got an exciting year of solar ahead, and I look forward to, working with you and getting a lot more installations over the line across Australia. I know there's been a lot of, regulatory changes and things for solar over the past 12 months, and Enphase will continue to provide support to getting those systems in for installers on the networks.
Yeah. Oh, one question. I got a juicy one then. So with emergency backstop in Victoria, so the system, so the networks, the DNSPs can remotely control your system. They can curtail it if the solar feed to the grid is too high. So where are we at with that for Enphase? Like, do we have a solution for that, or are we still installing systems zero export, or what's your update there?
Yeah, so Enphase are have got a constant communication happening with the DNSPs, the utility companies, for the emergency backstop for Victoria, and there are continuous programs to ensure that the products will communicate in a manner that will work on an ongoing basis with all the utilities. Now, this is I think it's been a mammoth job for manufacturers delivering this requirement into the industry, and there is it's very complex to do with software, both on the manufacturing side and also on the utility side. And I think it's still, there are still going to be some processes to be improved upon for all manufacturers for that system to really work effectively for the entire market. It's been a real frustration for manufacturers, actually.
Yeah, it's been a real big problem for a lot of people. But so for now, the new installations in Victoria are zero export until the DNSPs can get their crap together.
That's correct. Until all of the approval processes are sort of signed, sealed and delivered. But it's a very active programs.
Yeah, but the export that people are getting now is so little. It doesn't really make a difference anyway. People are generally trying to just maximise their self-consumption. So
and that's where the focus of solar should be now, right? And any export value that's being received is a bonus, and because in the future that's not going to exist in the solar industry, just with the amount of solar systems on the grid. So we're going to see more systems going in with storage to maximise the self-consumption in the home, minimise consumption from the grid.
Yeah, and you guys, are you compatible with Amber currently?
We're working on compatibility with Amber, yeah.
Okay, cool. We had Amber in a couple of weeks ago. It's really, really cool stuff there.
Yeah, amazing.
So,
yeah.
A good way to really maximise your system or maximise the benefits you're getting out of your battery if you go down the road with Amber. What about other VPPs? Is there any other VPPs you're on right now, or?
Not actively, but we are working on programs, yes.
Okay, cool. All right, well, we'll keep an eye out for that. But yeah, we'll leave it at that. Thank you for coming in, Duncan. That was good. If you have any questions, put them in the comments on YouTube or whatever you're listening to, and we'll try and get back to you. But yeah, that's it. All right, thanks, guys.
Thanks, Luke. It's been great.
All right, thanks.
Cheers.